The date is January 16th, 2026. If you've been following the celestial anomaly known as 3I Atlas, you know we've been waiting for the other shoe to drop. Well, it just did. And frankly, the data we are looking at tonight doesn't just challenge our models, it effectively breaks them. Let's look closer at the data coming in from the Hubble Space Telescope. New images taken just 8 days ago on January 7th have confirmed a feature that astronomers had only whispered about until now. We are looking at a high-resolution composite of the interstellar object, and unmistakable in the frame is a sharp, coherent structure, a powerful, narrow jet pointing directly toward the Sun. In the context of standard cometary physics, this shouldn't be there. Comets, as we know them, are dirty snowballs that heat up as they approach the inner solar system. They outgas, releasing dust and volatiles that form tails. But those tails are dictated by two fundamental forces: solar radiation pressure and the solar wind. Both of these forces work to blow cometary material away from the Sun. That is the rule. It is a rule that has held for every comet observed since the dawn of telescopic astronomy. 3I Atlas is breaking that rule. This new jet is an anti-tail in the most extreme sense. It is moving straight into the teeth of the solar wind, fighting upstream against the radiation pressure, and it is winning. The structure extends roughly 400,000 km from the nucleus. To put that in perspective, that is a jet of material stretching the entire distance from the Earth to the Moon, maintaining its cohesion against forces that should be scattering it into a diffuse cloud. This contradicts what we previously thought about the object's activity mechanisms. When we first saw hints of this in the July 2025 data, there was a hope that it might be a projection effect, a trick of the light caused by our viewing angle. That hope is now gone. This is the moment where I should mention that if you want to stay ahead of this rapidly evolving story, you should verify that you are subscribed. We are tracking this object daily, and as we get closer to the March events, the updates are going to become critical. Using the Larsen-Cecchinina rotational gradient filter, an image processing technique designed to bring out subtle contrasts, astronomers have revealed that this sunward feature is actually the dominant component of a complex triple-jet system. But unlike the other fainter jets, this sunward spike is tightly collimated. It isn't fanning out, it's a beam. The stability required to maintain a structure like this, 10 times longer than it is wide, while plunging toward the Sun, implies an intrinsic velocity and a material density that we simply do not see in natural evaporation processes. This suggests a nozzle. It suggests a constrained release of energy or matter that is impervious to the standard environmental pressures of our star. So, what does this actually mean? It means we have to discard the passive comet hypothesis. A passive body does not behave this way. If this were simple sublimation, the gas would expand in a broad cone sunward before being swept back. The brightness of the jet is another puzzle. At this distance, it is inexplicably luminous. This suggests the particles within the jet are either incredibly heavy or they are being replenished at a rate that is frankly staggering for an object of this size. The jet was already visible in July 2025, meaning the phenomenon is persistent. It isn't a momentary outburst. It is a continuous, stable state. We are watching something that has been on for months, maintaining a precise orientation relative to the Sun despite moving through space. This leads us directly into the orbital dynamics, where the coincidences stop looking like accidents and start looking like geometry. By tracking the subtle wobble of that sunward jet, astronomers have reconstructed the spin axis of the nucleus. Imagine the object as a spinning top. The axis of that spin isn't pointing randomly. Measurements indicate that the rotation axis of 3I Atlas is aligned with the Sun to within about 7 degrees. This is an extremely unlikely configuration. In the chaotic gallery of interstellar objects, spin axes are distributed randomly. Tidal forces from the Sun are far too weak at these distances to have torqued the object into this alignment. It presumably arrived this way. But the coincidence goes deeper. Not only is the pole pointing at the Sun, but the object's trajectory is also closely aligned with the ecliptic plane, the flat disk where Earth and the major planets orbit. Most interstellar objects like Oumuamua or Borisov come from random inclinations, dropping in from above or below at steep angles. 3I Atlas is different. It is sliding in almost perfectly flat. When you combine these two factors, a pole pointing at the Sun and an orbit on the ecliptic, the combined geometry is statistically improbable at better than 1 part in 10,000. In probability theory, when you see a 1 in 10,000 chance event, you have to ask if the underlying assumption of randomness is wrong. This alignment essentially turns 3I Atlas into a stabilized platform, keeping its eye or its nozzle fixed on our star. I want you to answer in the comments below. At what point does a series of statistical improbabilities stop being a coincidence and start being evidence? The precision of this alignment becomes even more critical when we look at where 3I Atlas is going next. It is on an intercept course. We are watching a set of initial conditions that seem perfectly tuned to facilitate a specific event in the outer solar system. The object is heading toward the domain of Jupiter, and the timing is practically synchronized. We need to talk about the Euphemy connection. There is a scenario where 3I Atlas could interact with the region of this specific Jovian moon to deploy or deposit material. If 3I Atlas is a mothership, this boundary is the perfect drop zone. Jupiter is massive, but even its gravity has limits. At the encounter distance of 53 million kilometers, Jupiter's escape velocity is merely 2.2 kilometers. 3I Atlas is moving at 66 kilometers. It is moving roughly 64 kilometers too fast to be captured by Jupiter's gravity alone. For any part of 3I Atlas to stay in the Jovian system, it needs to lose that 64 kilometers of relative speed instantly. This contradicts what we previously thought about fragmentation. In a natural breakup, pieces drift away at 5 or 10 meters per second. We need a kick of 60 plus kilometers per second. There is no known natural mechanism for a small icy body to explode with enough force to halt a fragment dead in its tracks without vaporizing it. To accelerate a fragment backward at 60 kilometers requires an energy release comparable to a tactical nuclear detonation. Therefore, if we see a new moon appear around Jupiter after March 17, 2026, we are not looking at nature. Nature doesn't have a braking thruster or perform orbital insertion burns. If the sunward jet we saw was actually a braking burn performed early to fine-tune this arrival, then the picture becomes coherent. This connects to the concept of the Bracewell probe, theoretical autonomous spacecraft sent to monitor other star systems. The impossible kick required to leave a calling card at Jupiter is the smoking gun. The sheer improbability of the alignment combined with the impossibility of natural capture physics creates a corner that the natural object hypothesis can no longer maneuver out of. We are forced to consider the alternative. The persistent sunward anti-tail, the improbable geometric alignment, and the targeted passage through Jupiter's domain make 3I Atlas the most anomalous interstellar object ever observed. It makes Oumuamua look like a simple rock. We are staring at a potential technological signature, data that cannot be generated by the background noise of the universe. March 2026 offers a rare and potentially decisive test. This is not a drill. The encounter will be monitored by Earth-based telescopes and by NASA's Juno spacecraft, which is already in orbit around Jupiter. Juno is perfectly positioned to detect the aftermath. If 3I Atlas fires a thruster to slow a probe down, Juno's instruments might detect the plasma disturbance. If a new moon appears, Juno's camera can hunt for it. This contradicts what we previously thought about our readiness. This time, we are waiting at the finish line. If nothing happens and 3I Atlas flies away intact, we are left with a massive natural mystery. But if something stays behind, humanity changes. We move from a species guessing about life to a species studying an artifact left on our doorstep. Whether it is a freak of nature or a messenger from the stars, 3I Atlas has already earned its place in the history books. Until March, keep looking up.